Hello everyone, and once again, welcome to our discussion over my YouTube channel. And this time we have another application of derivatives, and this is used to find the angle between two curves. Now, if this is your figure, so the angle between two curves at the point of intersection is defined as the acute angle between their tangents at the point of tangency. So, if this is the point of tangency, this one, so I can draw a line tangent to my curve, C tangent to f of x, no? And we call this as t sub 1 being my first curve, and we have another tangent T2 which is tangent to the g of x. Now, if these two tangents do not intersect at 90 degrees, so there is a pair of acute and obtuse angle. So the angle between the two curves is the acute angle between their tangents. So we are interested to solve for this angle. Okay? Now, by formula, that can be solved using this. Now, actually, from our analytic geometry, this is taken from the relationships of angle of inclination. So, that is the basis in arriving with this formula and finding the angle between the tangents. So, it is a ratio between the difference of the slopes of this tangent. So, over 1 plus the product of two slopes. Now, in order to obtain an acute angle between the tangent, then we have to consider this ratio as positive. So we take it as an absolute value because sometimes you will arrive with a negative result. So if it's a negative result, then ang ato karong value will be taken in terms of an absolute value so that the angle that we can obtain will always be an acute angle. Okay? Now, suppose we are given a problem with two curves involved. By the way, your M2 is the slope of your T2, your M1 is the slope of your T1, then P1 is the point of intersection. Now, in problem number 1, now, so we have to start with the point of intersection now because it's not given in the problem now. So, usually, the point of intersection will be solved. No? Now, in solving for the point of intersection, from the second equation, I may solve for x. The second equation is simpler than the first, no? So, I have to substitute my second to my first equation. Now, to avoid having a presence of radical, now, so it is x that is to be replaced with y. So, what is x from y equal to the square root of x? So, if I'm going to take the square both sides, so x is equal to the y squared. Then, substitute that to the first. Now, actually, it's also another option to have my y be replaced with the square root of x, but my equation will contain radical, and that is more complicated than having this, no? Wherein I can have my equation which is a polynomial, which is in polynomial form. Okay? Now, substituting my x with y squared, so I have 2y, so minus 3 equal to 0. So, this is factorable, no? One of the factor is y plus 3, the other factor is y minus 1. Solving for the zeros, we have the first value of y is negative 3 out from this factor, and I have 1 or y sub 2 equal to 1 from the second factor. But if I have to look at these results, no? Looking on the equation, y equal to minus 3 is not possible for us to use. Why? In the second curve, which is this one, no? The only value for y is only a positive value because if we take y being equal to the square root of x, so this will not produce any negative result. So I simply disregard the first value which is minus 3. Okay, so the only value of y that is considered in the point of intersection is 1. So if y is equal to 1, I can substitute out from the first or maybe the second. Okay, but I prefer to use the second because that is simpler. So when x is equal to 1, then y is also equal to 1. Now, after knowing the point of intersection, then I can now proceed finding the slopes. Okay, in order to use the formula for the angle between two curves later. Okay, now, what is the slope of my first curve? Now, if it is a line, No? So we can have this be reduced into a standard form of an equation of a line where there is a slope visible. No? But since we are in application of derivative, so another option is to differentiate this equation implicitly with respect to x. What is the derivative of x with respect to 1? To x. That is 1 actually. No? Okay. The derivative of 2y is plus 2y prime. 3 becomes 0. So 1 plus 2y prime is equal to 0. So my first value of my derivative, which also represents as m1, is equal to negative 1 half. So another option, as I've said, so I can write my equation in y equal to mx plus b form. No? So that my coefficient of x is actually your m. No? So rewriting my equation following this form, so y is equal to a negative 1 half of x plus 3 halves. So my m is equal to negative 1 half, the coefficient of x. Actually, this is your y-intercept. But what I need is the slope of my line. So the slope is actually the value of your first derivative, and that's equal to a constant value of negative 1 half. Okay? Now, finding the slope of y equal to square root of x, so I also have to differentiate. No? Following the rule in differentiation, that is y prime equal to 1 over 2 the square root of x. Since the value of the slope is variable, so I can now consider my specific location of my point or specific location of my curve. No? So the curve has a point containing 1, 1, no? Being the point of intersections between them. No? So substituting this, so y prime is equal to 1 half, and that's the value of your m2. Now, after knowing all the values of the slope, so you are now ready to use the formula. Okay, in order to solve for the angle between them. By formula, so the tangent of the angle between them is equal to the absolute value of a ratio where the numerator is a difference of two slope, m2 minus m1 over 1 plus m2 times m1. Then I have to substitute value. m2 is 1 half. m1 is a negative 1 half. So we have 1 half minus a negative 1 half, or that is 1. And the denominator is 1 plus 1 half times a negative 1 half. So 1 minus 1/4. So this is 3/4. Okay? So it is the reciprocal of 3/4, or that is 4 over 3 for the tangent of the angle between them. So taking the arctan of 4 over 3, then that will give you a result of 53.13 degrees being the angle between the two curves. Now, to answer, so this is just enough, no? If the only question is only to give the angle between them, no? But just to visualize, no? So I may also have the graph. Okay? So this is now the graph of our given curves, and these are the tangent. This is the line. At the same time, that's the tangent, correct? And this one, this is also another tangent to the y equal to the square root of x. So this is the point of intersection. So we have a pair of obtuse and a pair of acute angle. Okay, now, if you choose ganina to solve for the value of or the location of the point of intersection this way, so this is my equation, and if you substitute your y directly with square root of x, no? So you will arrive with an equation which is containing radical. No? So the equation is containing radical term. Okay? And we know that in our algebra before, so to solve an equation involving radical, so we can isolate a radical term. And we can associate terms with no radical, so place them on one side of your equation. So 3 minus x. And I can apply raising to power equal to the index of the radical to eliminate the presence of radical in your equation, or to convert the equation into a polynomial form. Okay, so this is 4x. This is a perfect square trinomial product. Okay, so we have 9 minus 6x plus the x squared. Rearrange x squared minus their sum is minus 10x, so plus 9. Factorable, and we have x minus 9 as one of the factor, and x minus 1 with roots of 9 and 1. But if you have to go back to your first equation, na, so there's a value here which cannot be used as a root because in working with equation in radical, no, so don't forget that there is a possibility of arriving with what we call as an extraneous root, no. So ang x equal to 9, so obviously cannot satisfy the equation because if you have 9 here, 9 minus 3 itself, no, the sum of these two, no, is already not equal to 0. So the equation is not satisfied. The more if I'm going to include the middle term which is 2 square root of 9. No? So this equation is not true when I'll be using 9. So 9 here is the extraneous root. So the only value that can be used is 1. So if it is 1, then the point of intersection is at point with coordinates of 1 and 1. Okay? Now, second, we have another curve. No? So just to practice on how to solve. No? So what is the first thing that I did? No? So I simply go with the point of intersection. Then after that, I solve for the slopes, no, using the first derivative of the function. Then I apply the formula for the angle between the two curves. No? Okay, so finding the point of intersection. I think the second equation is simpler than the first. No? So I have to find way on how to substitute my secant to the first. So it's either you solve for x or you solve for y. But y here is in first degree, so it's good to have my y be solved in terms of x and my y is equal to 8 over x and substitute that to my first equation. So second equation is y equal to 8 over x, so substitute to the first equation. So I arrive this as my equation in purely x variable. No? So we have 8 times 8 over x, so that is 64 over x. Removing the denominator by multiplying with x, so we have x cubed equal to 64. Taking the cube root of 64, so there I obtain x equal to 4. Now, if my x is equal to 4 and y is also solved being 8 over x or 8 over 4, so my y will come out to be 2. So the point of intersection, which can be used also as a point of tangency, so has coordinates of 4 and 2. Then you can proceed finding the slopes. Okay? Now, x squared equal to 8y. If differentiated with respect to x, so by implicit differentiation, x squared becomes 2x. Derivative of 8y is equal to 8y prime. And a point of tangency is considered, which is the point of intersection. So I have 2 times x, which is 4, and that's equal to 8y. So y prime, 8y prime, so y prime is equal to 1, which is also the value of the slope of your first curve. Okay, now, in the second curve, also by implicit differentiation, differentiate each term with respect to x. Okay, so product rule is applied. So we have x with y prime plus y with the derivative of x, but that is 1. So it becomes 0. Solving for the y prime, so I have a ratio of minus y over x, and I have to consider a point of tangency, which is the point of intersection. So we have coordinates of 4 and 2. So x is 4 and y is 2. So if your y is 2, so I have minus 2 over 4. So my y prime or my m2 or the slope of the second curve is equal to a negative 1/2. Now, using the formula to find the angle between them, okay, so there I have to substitute my m2, which is a negative 1/2, subtracted with 1. And we have a denominator 1 plus a negative 1/2 times 1. So if this is simplified, then this will produce a result which is minus 3. But since I have to consider the absolute value of this result, then we can have a tangent of the angle between them, which is equal to 3. Arctan of 3 will give you a value which is 75.565 degrees as answer. And again, to visualize, no? But actually, this is not needed, no? So you may stop until here to give the angle by giving the angle, the value of the angle, but just to visualize the given, so I have to show the figure. Okay, so the first curve is a parabola. This is x squared equal to 8y. And the second curve, which is xy, is actually this one. Actually, this is a hyperbola. Na? So, this one. Okay, so this is the point at which the two curves will intersect with coordinates of 4 and 2. Okay, and if you draw the tangent to the parabola, this one. Okay, so there you have the tangent. And if you draw another tangent to this curve, no, the having an equation of xy equal to it, no, so this is now your your tangent. So the angle between them, if I'm looking for the acute angle, so these are the pair of acute angle, and this is the pair of obtuse. Now, if in case the obtuse angle is also needed, so it's easy to determine the obtuse angle between them, because if this is the acute, no, and that's the obtuse, the sum of these two is equal to 180 degrees. So, the obtuse angle, if needed, is equal to 180 degrees minus the angle you solve. Okay? So, that's all for today. No? So, I'm again inviting you to subscribe to my channel if ever you're not able to subscribe yet. And if you're done, so you can also share and invite others to do subscription. Okay, so thank you for watching and following. So, until the next tutorial video. Okay, bye-bye and good day.